Hello. So today we are going to do the next part of synopsis of binomial theorem, in which I told you that I will give you some formulas regarding multinomial theorems. As you know what is binomial, so it's very clear what is multinomial. In binomial, you just have x plus y whole raised to n, whole power n. But in multinomial, it is something different. Instead of just x plus y, two terms, you will have like something like x1 plus x2 plus x3, like that it goes up to xn and then whole power n. So here you have not only two terms, but multiple number of terms. That is why it is multinomial theorem. Now the first formula we are going to learn is, if you want to write expansion of x1 plus x2 whole power n, it is just binomial expansion. Then how will you write? You will write sigma n factorial, which comes from the power n. In the bottom, you will have r1 factorial, r2 factorial. What are these r1 and r2s? It depends, because r1 and r2 total, it must become n. In such way, you can take r1 and r2. And then x1 power will be r1, x2's power will be r2. This is the general term in the expansion. And if you want the sum, you will put sigma, sum of all the terms. Similarly, in multinomial, like if you have x1 plus x2 plus x3 up to xn whole power n, this expansion is sum of many terms. What are the terms looking like? N factorial. This n factorial came from this power n. But then you will be having r1 factorial, r2 factorial, r3 factorial being multiplied up to rk factorial. But how will you select this r1, r2, r3? You will see that when you add r1, r2, r3, so on up to rk, total you must get n. And then you will take x1 power r1 multiplied to x2 power r2 multiplied to x3 power r3. In this way, the multiplication goes up to xk power rk. So this is the general term. This entire thing can be called as general term in the expansion of this multinomial. Now, how many terms in this expansion you can find? In this multinomial expansion, you can find number of terms. What are they? They are non-negative integral solutions. The solutions which are integers of the equation. Which equation I'm talking about? R1 plus R2 plus R3 up to Rk equal to n. And what is that equal to? Already you have learnt in permutations and combinations. Total you have k terms. So the number of solutions will be n plus k minus 1 c k minus 1. and that only will be the number of terms in the expansion. I'll give you one example for this. For example, I am giving you 2x plus y plus 3z whole power 10. And if I want to find the general term, how will I find? So I will take from the power 10, I will write 10 factorial. Then because there are 1, 2, 3 terms, I will have R1 factorial, R2 factorial, R3 factorial. Now, how will I select this R1, R2, R3? R1 plus R2 plus R3 should be the total n. This n, total 10 it should be. And then the first term, 2x, will have power R1. Then the second term, y, will have power R2 into the third term, 3z, will have power R3. So this is the general term. Now, in the same expansion, like this is one example. So the second example, I am giving you 2x plus y plus 3z whole power 10 again. And I'm asking you, find the coefficient of the term x cube y square z power 4. So what we will do is, we will take the general term I have taken above. What is the general term? 10 factorial by R1 factorial into R2 factorial into R3 factorial, 2x power R1 into y power R2 into 3z power R3. So the power of x is 3. So R1 should be 3. Power of y is 2. So R2 should be 2. Power of z is 4. So R3 should be 4. I told you R1 plus R2 plus R3 should be equal to the power 10. You can see 3 plus 2, 5. And 5 plus 4, 9. 5 plus 4, only 9 is there. That means what should be there? There should be one more. It's not x cube, y square, z power 4. Something else should be there because total 10 should be there. So you can't take this combination. So what we will do? We have to take like this. We have to take z power 5. Z power 5. That means R3 will be 5. Now you see, when you put R3 as 5, you will have 3 plus 2 plus 5 equal to 10. Is that clear? So this is how you will decide about R1, R2, R3. Now, after deciding that, the coefficient you have to find. So how will you find the coefficient? You will take 10 factorial by R1 factorial 3 factorial, R2 factorial 2 factorial, R3 factorial 5 factorial. Then 2 power R1 is 3. Of course, x power is also 3 into then y. Y power is 2. So that I'm not writing. Coefficient is 1, of course. And then 3z. 3 power is R3. So 5. Z power is 5. So we are finding the coefficient of x cube y square z power 5. And this is what we will get. This is the answer. Coming to one more example. Suppose if I give you 2x minus y plus 4z whole power 12. I have to find total number of terms in this expansion. So how will I find? Because there are 1, 2, 3. It is a trinomial. That means I will be having R1 plus R2 plus R3, and that should be equal to 12. So the number of terms k is 3. The power n is 12. And so in this equation, I'm talking about this equation. So the number of solutions, number of non-integral solutions of this equation R1 plus R2 plus R3 equal to 12 will be n plus k minus 1 c k minus 1. That is 12 plus 3, 15 minus 1, 14 c2. That means start with 14, take two numbers by 2 factorial, 2 sevens. So total 91 terms are there in this expansion. Okay, so we came to know how to use these formulas. Let us go to the second formula. If you want to find coefficient of like a1 power n1 into a2 power n2 into a3 power n3, like that it goes on up to am power nm. If you want to find in the expansion, actually what is this multinomial expansion? Till now I did not say. The multinomial expansion is a1 plus a2 plus a3 up to am whole power n. Its coefficient we are finding. So the formula for coefficient is n factorial, which comes from this n. And in denominator, you will have n factorial in n1 factorial into n2 factorial into n3 factorial, so on, into nm factorial. One thing you have to remember. What is that one thing you have to remember? N1, N2, N3 up to Nm. If you add up to Nm, total you must get the power n. That is very, very important. For example, I will give you like this. You have to find coefficient of a power 4 b cube c square d in the expansion of a minus b plus c minus d. We will take minus d. Instead of plus d, we will take minus d. So minus d whole power 9. So when you find the coefficient, first of all, you are having multiplication of 4 variables. So you will take minus 1 power 4 in this. And then afterwards, from the power 9, you will have 9 factorial. And then in denominator, a power is 4, so 4 factorial. B power is 3, so 3 factorial. C power is 2, so 2 factorial. D power is 1, 1 factorial. And you can easily see the powers 4 plus 3 plus 2 plus 1. When you are adding, are you getting 9? You are not getting 9. 7 plus 2 plus 1. 4 plus 3 is 7, plus 2, 9, plus 1. You are getting 10. That means you can't take this. The power can't be 10. The power has to be 9. So what we have to do? We have to reduce one power. Like, I will remove 3. For B, I will write square. The power of B, I will write square. So here also I will have 2 factorial. The 3 will be made as 2. Now 4 plus 2 is 6 plus 2 is 8 plus 1, 9. We are having total power 9. And this will be the coefficient. This will be the answer. So this is how you have to do it. Let us take one more example after writing the formula. So the third formula I want to tell you is finding greatest coefficient. In the expansion of, this is again a multinomial. The expansion is a1 plus a2 plus a3 up to am whole power n. So the greatest coefficient will be n factorial by q factorial power m minus r and q plus 1 factorial power r. Now, what is this q and r? Of course, m and n you have here in the expansion. What is q and r? So, q is the quotient. R is the remainder. Quotient and remainder where? When you divide the n by m. So there must be a division. This you can understand better if you take one example. In the example, I'm asking you greatest coefficient in the expansion of x plus y plus z plus t whole power 50. So first, there are 4 terms. So m is 4. The power n is 15. So I will divide 15 by 4. Then I will have 4 3s, 12 minus 3. So quotient q is 3. Remainder r is also 3. So when I write greatest coefficient, as per the formula, the power n is 15 factorial. Q, the quotient is 3 factorial power m minus r. 4 minus 3, 1. Then Q is 3. 3 plus 1 is 4 factorial. Power r is 3. So this is how I have the formula. As per the formula, the greatest coefficient. These all you have to apply while doing problems. Okay, let us take the next formula. If you want to find the term. This is fourth formula, I think. Let me see. Yes, third formula over. Yes, so fourth formula. If you want to find the term free from radical or rational in the expansion of, that means there should be no radical, no rational power. Rational in the sense, rational power. In the expansion of a power 1 by p plus b power 1 by q whole power n. Remember, a and b are primes, prime numbers. So in what way you can find? So first of all, this power n I will make small n, and then I will write the general term. TR plus 1 is NCR, A power 1 by P power, I have to take n minus r, B power 1 by Q, I have to take power r. Now I have to inspect this carefully, and I have to put the values of r carefully between 0. You can take from 0 to n, any value for r. That is the thing that you will know if you observe one example again. So the example related to formula, I will give you the expansion fourth root of 9 plus sixth root of 8 whole power 500. But if I write like this, 9 power 1 by 4 plus 8 power 1 by 6 whole power 500, 9 and 8 are not prime numbers. So I will write 9 as 3 square power 1 by 4. So it will cancel and become 3 power half. 8 I will write 2 cube power 1 by 6. 3 ones, 3 twos. And then whole power 500. So I change the question as 3 power half plus 2 power half whole power 500. Now I have to find the term free of radical. The term free of radical in this expansion. So first of all, I will write the general term. NCR, then 3 power half will have power 500 minus R. 2 power half will have power R. Now carefully, if you observe the powers, 500 minus R over 2 divided by 2 and R over 2, I have to select R starting from 0 till 500. Such a way that this rational will disappear, rational terms. The radical terms will disappear. That means R I can select 0, all even numbers, 2, 4, 6, 8, up to 250 I can select. So total I can say how many values. R I can take up to 500. R I can take up to 500. Not only till 250, I can take from 0 to 500, but all even numbers. But what I am saying is, out of 500, I am taking only even terms. That means these all come up to 250 terms. Half. From 1 to 500, if you count 1 to 500, we have half even terms, half odd terms. 250 even terms, 250 odd terms. I'm taking even terms and then I'm adding 0 to it. So there are 251 terms free of radical in this expansion total. Okay, let's go to fifth formula. Actually, this fifth formula is very complicated, but just I'm telling you so that you can use it when necessary. Suppose if you have square root of a plus b whole power n is some I plus f. Remember, I and n both are odd integers. They are odd. And f is a fraction. So it will be starting from 0. It will be from 0 and it won't occupy 1. It will be between 0 and 1 only, this f. Then I can say I plus f into f will be equal to k power n. What is this k? I did not tell anything about k. If you take a minus b square, that will be k. It will be greater than 0. And remember, root a plus b should be less than 1. These all things will look difficult now. If you take one example, it will become easy. Not only that, you can say one more thing about this. If the power n is even, then I can take I plus f into 1 minus f. It will be equal to k power n. So this is all about this. When examples comes, I will point out at this. I will tell you. Let us go to the sixth formula. How the expansion of 1 plus x whole power n look like? It looks like 1 plus nx plus n into n minus 1 into x square. Like that it goes on. But remember, modulus of absolute value of x should be less than 1. That is the condition. And already I told you 1 plus x power n. If there is an expansion, the number of terms in this expansion will be n plus 1 terms. That you have to be clear because I'm repeating it again. Okay, next we will go to eighth formula. If we have 3 consecutive binomial coefficients, 3 consecutive binomial coefficients, what do you mean by them? Coming one after the other. Like if there is NCR, the next will be NCR plus 1, the previous would be NCR minus 1. So if you have like this, they are said to be in arithmetic progression. Like if I say they are in arithmetic progression, then for one thing I can be sure I'll say that R will be equal to 1 by 2 into n plus or minus root n plus 2. These all also, when it comes to formulas, you will understand very well. Now it looks very confusing. So I don't want to express about this. And moreover, the 3 consecutive binomial coefficients, they can never be in AP. If they are in AP, this is the condition. Now, apart from this, in binomial theorem, we have some shortcut methods also. Wherever possible, I will try to give examples for these shortcut methods. We will learn some shortcut methods here. For each shortcut method, I will give you one example. The first one, suppose I have to find coefficient of x power m in the expansion. Oh, I have written the spelling of expansion wrong. So let me correct it. In the expansion of ax power p plus b by x power q whole power n. That will be nothing but coefficient of tr plus 1. But what is this r? R is nothing but np minus m by p plus q. That's the formula to find r. As I told you, I will give you one example. So in this example, I am asking you to find coefficient of x power 4 in the expansion of the binomial expression I'll give you is x by 2 minus 3 by x square whole power 10. So first of all, I will change this. I will write 1 by 2 x power 1 minus 3 by x power 2 whole power 10. I will change like this. Why am I changing like this? So that I can write some important things. Because my formula, I have TR plus 1. Coefficient of TR plus 1. What is R? I have to find first. So for that, I will compare. A in the formula is 1 by 2. Then P in the formula is 1. Next, B in the formula is minus 3. Q in the formula is 2. Lastly, N in the formula is 10. With the help of this, I can find R. NP 10 into 1 minus M. Okay, what is this M? Coefficient of x power 4. This 4 itself is M. So 10 minus 4. P is 1 plus Q is 2. So I have 6 by 3, that is 2. So coefficient of TR plus 1, T2 plus 1. That is, I have to find coefficient of T3. T3 term. So how will I find coefficient of T3 term? In the expansion, the power n, C, R will be, because T3 term we are finding. So for that, what will we have? 10 is the power, like I am taking the expansion 1 by 2x minus 3 by x square power 10. So 10C R, that is, it will be 2. Then I have to take 1 by 2 because I'm finding only coefficient, I won't take x. So 1 by 2 power will be 10 minus 2. Then I have to take minus 3. The power of minus 3 will be just 2. This is how I'm getting only coefficient. That is why I'm not taking x. So I have given you the shortcut formula and the related example. Let us see the second one. The second one is giving you shortcut formula for the term, 1 second, I will erase. Okay. So I'm writing the term independent of x in the expansion of same kind of expansion, ax power p plus b by x power q whole power n is again tr plus 1 term. And here r is again taken as formula np by p plus q. So we know what is n, we know what is p, what is q. Nothing to be found out. Everything will be given. So now the example I'm going to give you is you have to find term independent of x in the expansion of x square minus 1 by 3x whole power 9. That I have to find. So that will be tr plus 1. So what is this r? I have to find out first. To find r, I will compare. A is 1, P is 2, B is minus 1, the power Q is 1. But what is this 3? So B you have to take total minus 1 by 3. You can't just take the numerator. B will be total minus 1 by 3. And the power n is 9. Now first I will find R. NP 9 into 2, 18 by P plus Q 2 plus 1, that is 3. So R is 6. Once I get R as 6, now I can find term independent of X. That will be TR plus 1, T6 plus 1, T7. How to get T7? First the power n is 9. C, R will be 6 because this is 7, R will be 6. Then what will be the power of x square? Actually, power of x square I need not take. I can take power of 1 because I don't want x, independent of x. The coefficient 1 power will be 9 minus 6, 3. And the coefficient negative 1 by 3 power will be 6. So that means 9c6 is 9c3. Then minus power 6 will be positive only. 1 power 6 is 1, 3 power 6. 9c3 means start with 9, take 3 numbers, 9, 8, 7, 3 factorial, that is 6 into 1 by 3 power 6. So first of all, 2 3s, 2 4s, then 3 3s. So I will have 28 by 3 power 5. And that is 28 by 243. That will be the term independent of x. Like this, whenever you get a new formula, take your own example and practice it. For these, I will not give you examples, just I will give you the shortcut methods. Suppose I have an expansion in expansion of x plus a whole power n. If I take tr plus 1 by tr it will be simply n minus r plus 1 by r into a by x in short. Similarly, fourth, if I take the coefficient of x power n minus 1 in the expansion of x minus 1 into x minus 2 into x minus 3 up to x minus n. That will be nothing but n into n plus 1 by 2. But it will have a minus sign. Similarly, if you take coefficient of x power n minus 1 in the expansion of x plus 1 into x plus 2 into x plus 3 into x plus 1. It won't be negative, it will be just positive n into n plus 1 by 2. Coming to the fifth one. Now we are finding if coefficients of pth and qth terms in the expansion of 1 plus x whole power n are equal. We are taking pth term, qth terms, coefficients from the expansion 1 plus x whole power n. If at all they are equal, then I can say p plus q will be equal to n plus 2. This is also just a formula. Coming to sixth formula. If the coefficients of x power r and x power r plus 1 in the expansion of, this is also binomial expansion, a plus x by b whole power n. If these two are equal, then I can say n will be equal to r plus 1 into ab plus 1 minus 1. Later on, you will definitely see problems of this kind. That's why I'm giving you this. The next formula is if you have to find sum of coefficients of the expansion ax plus by whole power n, it is nothing but a plus b whole power n. Okay, the eighth one, if you have to find the number of terms in the expansion of x plus a whole power n plus x minus a whole power n, that will be n plus 2 by 2 if n is even. Otherwise, it will be n plus 1 by 2 if n is odd. Similar to this, there is one more formula, the number of terms in the, I will erase this and write neatly. So, in the expansion of x plus a whole power n minus x minus a whole power n will be n by 2 if n is even. Otherwise, it will be n plus 1 by 2 if n is odd. Okay. Coming to the 10th formula. We are finding the number of terms in the expansion of x1 plus x2 plus x3 plus xr whole power n. That will be n plus r minus 1 cr minus 1. For this, I will give you one example. So I am asking you the number of terms where in the expansion of, I'll give something like 2x minus y plus 4z whole power 12. So first of all, looking at it, I have to write a few information. R, the number of terms R is 3. The power n is 12. So in the formula, if I put these values, first compare and find these values. So I will have n plus r minus 1, cr minus 1. That means 12 plus 3, 15, minus 1, 14, c2. Start with 14, take two numbers by 2 factorial. So 91 terms will be there in this expansion. Okay, let's go to 11th formula. The 11th formula is we are finding the number of terms where in the expansion of, which expansion I am talking about? I am talking about x plus y plus z whole power n. That will be same formula which we have used in 10th. Total r terms. So here r is 3 because we have total 3. The power n is n only. So what is the formula we have used in the previous slide? N plus r minus 1 cr minus 1. So n plus r minus 1 cr minus 1. That is n plus 2 c2. This many number of terms you can find in the expansion. Similarly, we have another formula 12. If you want to find sum of coefficients in the expansion of something like a plus bx plus cx square whole power n, then you can use the short formula that will be a plus b plus c whole power n. This you have learnt in PU also. Now in 13th, there are from 13th onwards, there are some important formulas which you have to by heart. I will just write down them. The first one is C0 plus C1 plus C2 plus C3 up to Cn can be written as 2 power n, or in short, sigma CR, R is from 0 to n. Then 14th one, C0 plus 2C1 plus 3C2, so on up to n plus 1 Cn. The answer for this or the formula is n plus 2 into 2 power n minus 1. When time comes, we will use all these formulas. 15th one, C1 plus 2C2 plus 3C3, so on up to NCN, N into Cn. That will be n into 2 power n minus 1, and this in short you can write sigma r into Cr. R is from 1 to n. That is what you can see here in short. The 16th formula is C0 plus 3C1 plus 5C2, so on, some odd number 2n plus 1. Cn can be written as n plus 1 into 2 power n. Coming to formula 17th, if you have sigma r into r minus 1 into NCR, actually I need not write NCR, but here I will write because r is from 0 to m. So in the answer you will have clearly n into n minus 1 into 2 power n minus 2. That is why I'm mentioning n. Otherwise, I would have mentioned just CR. 18th formula is if you have sigma r into r minus 1 into r minus 2. Okay, r into r minus 1 into r minus 2 into NCR, where r is from 0 to n. It can be taken as n into n minus 1 into n minus 2 into 2 power n minus 3. Then comes 19th formula. C0 minus C1 plus C2 minus C3, so on, minus 1 power n Cn can be taken as 0. Similarly, in 20th formula, C1 minus 2C2 plus 3C3 minus 4C4, so on, when it will come to minus 1 power n minus 1 into n into Cn, that also will be 0. Okay, 21 formula and 22. The last two formulas I will write on the last page. 21 is 1 square into C1 minus 2 square into C2 plus 3 square into C3 minus 4 square into C4. So on it will go up to minus 1 power n minus 1 into n square into Cn. That will be 0 again. So usually in these formulas, when you have alternate plus and minus, you have seen it is becoming 0. The next is 1 cube into C1 minus 2 cube into C2 plus 3 cube into C3 minus 4 cube into C4 and so on. In the end, minus 1 power n minus 1 into n cube into Cn if you have, that also will be 0. So till now, you have learned some synopsis points and shortcut formulas. These we will be using in the next class for doing some multiple choice questions, and some questions we will do in the long method. So by the time you come for the next class, learn all these synopsis points so that you will find the problems easy. So with this, we will end the class. See you in the next class.